Okay, so today we're going to prove identities to be true. Okay? An example of what we're going to prove is this right here. This time we're going to have an equal sign, and we want both sides to be equal. Okay? We want to prove that what is on the left side is in fact what is on the right side. Okay? Now, there's going to be many ways for us to do this. Okay? There's no right or wrong way. Well, there's not one right way. There are going to be some wrong ways. Okay? And we will talk about what those wrong ways are. Okay? 3 different ways you can prove an identity to be true. Okay? You can just manipulate the left side until it looks exactly like the right side. You could manipulate just the right side until it looks exactly like the left side. Or you can manipulate both sides until they look the exact same. Okay? It does not matter which one of these you do. Okay? You may start out trying to manipulate just the right side and get stuck, so you try to manipulate the left side even though that wasn't your intention. Okay? But you either focus on one side until it looks the same as the other, or you work with both of them until they look the same. Okay? Now, what do I mean by manipulate? Okay. When I say manipulate, that means you are going to use algebra skills as well as the 8 fundamental identities to change your expressions on both sides. Whether it be, okay, there may be some factoring, there may be some multiplying, there may be adding fractions. You okay? Good? Yeah. You have like a
I
scary.
was just super excited that you're going to use the trigger.
Okay, good. Okay, now, this is super important. We are proving identities to be true, okay? I do not want you to think of this as an equation. We want to take 2 expressions and show that they are the same. So, you cannot move things across the equal sign. You cannot add things over. You cannot multiply things over, divide things over, whatever. You are proving that 2 expressions are equal. So you cannot move things. It is not an equation. 2 expressions are equal. Okay? That is the biggest no-no out of everything. Okay, now, you already know that these can be frustrating. Okay? Be prepared to think. Okay? The nice thing is you have a stopping point. When both sides are the same, you know that you are done. You have something that you're working towards. Okay? Which is, I think, going to be better than yesterday when you were just trying to simplify. Okay? But be prepared to think. These are not always going to be easy. Okay? You may have to skip a problem and come back. All right? It could be easier to start with the more complicated side. Okay? That way you have more terms or more functions to work with to try to get that down to something more simple. Okay? It could be helpful to start with the side with addition and subtraction versus multiplication or division, especially if you are adding fractions, okay? It's going to be easier to add terms together as opposed to taking something that's being multiplied and breaking it apart. Look for opportunities to make substitutions. Okay, you have your fundamental identities memorized by now, right? Okay, if not, then you need to. You need to look for opportunities to substitute those identities in, especially when you see those Pythagorean identities. I'm hoping that over, like after your homework tonight, those Pythagorean identities really jump out at you, okay? Whether they're rearranged or not. Try to factor, okay? I know that it is uncomfortable to use algebra when we have trig functions, okay? Like I said earlier, if you need to change things to A's and B's and C's and factor it and then apply it to your trig expression, that's fine, okay? But there will be times where you are going to probably have to factor, okay? If you're really stuck, change everything to sine and cosine, okay? This is not a strategy that you should use every single time, okay? But it is a strategy that if you're stuck and you start changing things to sines and cosines, okay, those are easier to work with, all right? Simplify by combining fractions, okay? If you have two fractions that are being added, common denominators, add them together. It could be helpful to break up fractions, okay? If you have a fraction with more than one term in the numerator, you know that it is possible to break that into multiple fractions. So you can do that if you think it is going to help. Okay? Multiply by the conjugate. We did that problem on Tuesday where we had 1 minus sign in the denominator. We multiplied by the conjugate so that we could get that Pythagorean identity, okay? So you may see that as a helpful way. Okay? Keep the end in sight and do not give up, okay? You know where you need to get to this time, okay? You know that the right side needs to look like the left side, okay? So keep trying. Okay, this problem 47 that we did on the board, somebody did it in 2 steps, somebody did it in 10 steps. It does not matter how long it takes you as long as you get both sides equal, okay? So keep trying. If you get stuck, go to the next problem and come back. Okay, don't erase everything right away, but if you're really stuck, erase it and try again, but do not give up, okay? These are all just big puzzles that we need to solve. And the more you do, the better you will be. Okay? I cannot stress that enough. So let's do some examples now. Alright? I have 4 that we're going to do together. Okay? And then you have 10 maybe tonight. Okay? So here we go. This is the one that was on the front page. Okay. So first of all, we need to make a decision. Which side should we start with? The left side. Why would maybe the left side be better? Okay. It might be easier to add things together to get it to look like the right side as opposed to the right side making it an addition problem, okay? So what can we do on the left side? We can make cotangent cosine over sine. And we can make tangent sine over cosine. Okay. We're adding 2 fractions. common denominator. Okay. So I'm going to multiply this fraction by sine over sine, and this fraction by cosine over cosine. What? Okay. Not a question?
No.
Okay. Okay, so now we have a common denominator of sine cosine times sine, right? This first numerator is sine squared, plus the second numerator is cosine squared. What do you see? What is sine squared plus cosine squared? 1. Does the left side look like the right side yet? No, but we're getting closer, aren't we? Yes. We can split them apart. This is the same thing as 1 over cosine times 1 over sine, correct? All right. Well, what's 1 over cosine? And what's 1 over sine of x? What was the right side? Okay.
Will they ever not match, or will they always?
They will always be able to match. I'm always going to give you an identity. It is your job to prove it to me. So by manipulating the left side, we have proved that the tangent of x plus cotangent of x is secant x plus secant x. Your last step should be saying this equals this. And I always like to put a check mark saying, yeah, I got it, I'm proud of myself. Okay? You don't have to do the check mark, but that lets me know that, hey, I'm done. I got there. Okay? So in this problem, we just manipulated the left side until we got to what the right side was. Okay? But your last step, I do want to have something equals something. Now here, I am not going to make you write this right side over and over and over again. That's a waste of time. But make sure you write it again for that last step, okay? All right. Let's try another one. Okay. What side would you like to start with? Probably the left side. I don't even think you would want to try with the right side yet. Okay? What should we do with the left side? And how will we add them together? Common denominator. Okay. I'm gonna go ahead. So I can show my common denominators here. I'm going to rewrite it so I have room. Okay, so what are we going to multiply this first fraction by? Sine of x over sine of x. And the second fraction? 1 plus cosine of x. Okay. So our common denominator is the sine of x times 1 plus cosine x. My first numerator is what? Sine squared plus our second numerator. 1 plus 2 cosine x plus cosine squared x, correct? Now what?
Did you use foil on the signs?
Okay, first of all, Joey, yes, we
Yeah,
foiled
okay.
these. Okay, now you're telling me that there is a sine squared plus a cosine squared, which is 1, okay? Okay, just to save room, can I make 1 plus 1 2? You might let me. Thank you. Alright. Now what do you think? Okay, this is where you get really excited, right? You see 1 plus cosine and we see 2 plus 2 cosine. Okay, so Jenna says factor out of 2. When we factor out of 2, we now have common factors of 1 plus cosine of x. So we have 2 over sine of x. Okay, what was my right side? 2 cosecant x. And what's 1 over the sine of x? So we have 2 cosecant of x equals 2 cosecant of x. What?
So we got it.
You got it.
I guess it's balling, but.
We are balling. Okay. Questions? Okay. Now, what was nice about this problem is you had a homework problem that was very similar. So since we had gone over number 63, we kind of knew where this was going, right? Okay? The more problems you do, the easier these are going to be. Don't panic. What? What's it?
I'm gonna have to manipulate this.
We're potentially gonna have to manipulate both sides. It's possible to do it just with just one side, but we could manipulate both sides. Now, how many of you want to cross multiply? Gosh, it looks perfect for cross multiplying, doesn't it? We are not allowed to. Okay, this is not an equation. We want to show that the expression on the left is the same as the expression on the right. So which side would you like to start with?
Really matter.
It doesn't matter which side you start with.
Let's go left side.
And what would you want to do with the left side?
Okay, let's do the right side.
Okay, let's do the right side. What can we do with the right side? Okay, remember this in the denominator? We can multiply by the conjugate, correct? Okay. And when we multiply by the conjugate, okay, we have cosine of t times 1 plus sine of t. And our denominator becomes what? 1 minus sine squared t. The whole point of multiplying by the conjugate is so that we can get a Pythagorean identity. Look at your Pythagorean identity. What is 1 minus sine squared? It becomes cosine squared t. Then what?
Cancel out for the bottom.
Yeah, this cosine cancels out with one of these cosines, and so we have 1 plus sine of t over cosine t, which is exactly what we have over here. Okay. Now, let me be clear. You must show every single step. There is not a step here that I could have skipped. You need to show me that you are multiplying by the conjugate. You cannot just go from this original problem to this first step without showing me that that's what you multiplied. I'm not going to assume. Okay? And from step to step, we really only do about one thing at a time. We only manipulate one thing at a time. Okay? I need to be able to follow your work. Your neighbor should be able to follow your work. It should be clear what you replaced or substituted or rearranged. Okay? You will get docked if you do not put enough steps in. Okay? I know that some of you, by Tuesday's quiz, you are going to see a problem and you are going to be able to envision how to rearrange everything. That's great. Write it all down. Okay, this is our last problem. Where would you like to begin? What? Left side. Okay. Now, something that I want you to pick up on, I see a squared function along with a 1, which means you should look at your what identity? Pythagorean. Is secant squared minus 1 something special? Okay. It is tangent squared. Now what? Okay, so secant is the same as 1 over cosine squared. Is that what you're trying to say? Right? Okay.
Would you
Oh, okay. Maybe the tangents can go to sine over cosine or sine squared over cosine squared.
multiply by the reciprocal on the bottom?
Right. So when we actually perform the division, they cancel the sine squared. Okay. Here's an example, like once we got to tangent squared over secant squared, changing everything to sines and cosines was really helpful, right? We got some things to cancel. Does this feel better today? Okay. Every day we're going to get better at this. But you have to keep in mind that the more problems you do, the better you're going to get. Okay? So here are today's problems. Okay? You must come in here tomorrow with all of these attempted. You cannot ask me a question about a problem if you have not attempted it. Attempted it means you have something written down. Looking at it and giving up, that is not an attempt. You have to actually write something down to attempt a problem. Okay? Now, if you get stuck on number 17, do number 19 and 21 and then come back to 17. Okay? Don't just skip over it. Okay? This is really going to test your mental endurance. Okay? You can't give up right away. That's not going to help you later in life. Okay? We'll forget about math for a second. Okay? In life, you are going to be presented with challenges that you are going to have to push through. Okay? You can't get in the habit of giving up easily.
I'm done with my soapbox.
So